All right, hello and welcome back. This is data representation number 5, plan today. Talking about a little bit over data representation number 4, the homework. Just a few questions I want to look at real quick. Do some practice today on data rep 5. Talk about some simple fractions, Punnett squares, recessive and dominant traits. What's buoyancy? You ever heard of buoyancy? You ever heard of a buoy? Yeah, floats. We're going to talk about finding a definition. There's a couple questions in the second passage of our practice today where if you don't find the definition, you don't know what's going on. Direct proportionality, what's that look like? And then more dominant recessive stuff, sex-linked traits, and then a whole passage about stuff you're not going to understand, but you can still get questions right on if you match up and down arrows and pictures and letters. So let's jump right into looking at the homework from last time. Just a couple questions I wanted to look at on group work number 4 here. Homework number 4. I know you're not working in groups. Number 6, which gum has the viscosity of 100,000 at a lower concentration than any of the other 3? Looked at 100,000, draw a line over and said, where does it happen first? Looks like gum Y. So that one struggled. People are challenged by that one, it seems, most years. Not sure why. Number 14, most similar in thickness. You're just picking out the things that look the same width, guys. Outer core and lower mantle. Earth's radius. People struggled with this question. It says, look at figure 1, figure 2. How could I figure this out? Well, here's figure 1. Inner core, outer core, lower mantle, crust, space. Where does Earth stop? Crust. How big is that? Bigger than 6,000. That's the 6,400 answer there. Oh, excuse me. And number 19 was just a tricky question because when's it going to weigh less? It's going to weigh less if the value of the gravitational field, GE, is less. So if the gravitational field is less, like it is at 2,000, it will have less weight. So that was why that one was A. A couple of hard questions there on group work number 4, the ones I'm going to talk to. But where were those questions? You'll notice they were at the end of the passage. You're gonna notice that I've already marked up some of this one because I got a phone call when I tried recording this the first time and I messed up the pausing. So here I am talking about it again. Number 8, getting in passage talking about dogs. So number 8 asks us after cross 1 but before cross 2. Again, you're not gonna read anything, you're gonna jump right into questions. After cross 1, before cross 2, the student hypothesized that each of the parents in cross 1 capital B, capital B, capital E, capital E. Was this hypothesis consistent? We got this word consistent. Does it agree? If you didn't know what the word consistent meant, it's hard to answer that question. So was their hypothesis, which is, informed prediction about what they believed to be true, was it consistent with the results? And you go and look and see what do big B, big E look like, and they're black dogs. What does cross 1 say? We had all black dogs. Okay, cool. So that seems to be consistent because all the offspring had black coats. If all the parents had black coats and all the children had, if all the children had black coats, it seems reasonable that all the parents would have because all they have to pass on are these dominant alleles, which will result in the dominant trait, which seems to be a black dog. Second one. What was the gene B and gene E genotype of the offspring across 2 that had a brown coat? So you go look and say, what do brown dogs look like over here in the table? Little b's, at least one big E. Answer D there. Nothing more than just finding where it is brown. There's brown. Yep. 1, 2, 3. Third one, number 10, based on tables 1 and 2, of what fraction, cool, of the offspring of cross 3 had 1 or more copies of the capital E allele of gene E? And you guys say, okay, well, what's the capital E allele going to look like? You go up the table and you say, oh, capital E is black, black, brown. Okay, so we're talking about how many black and brown dogs came out of cross 3. 4 out of 6 reduces to 2/3. That's where answer option H is coming from. Okay, well, we can keep going on this. Number 11. Consider the offspring of each of the three crosses in tables 1 and 2. Some of the offspring of which crosses, because that's your question right there, which crosses could have had only recessive alleles? What does only recessive look like? Little b, little b, little e, little e. What would that kind of dog look like? Little b, little b, little e, little e. That's a yellow dog. Which crosses had yellow dogs? That's what question 11 is really asking. Which crosses had yellow dogs? But it's never going to ask it that explicitly. 2 and 3. Crosses 2 and 3 only. Because little b, little b, little e went along with yellow dogs. 4 down, 2 to go. Then you got to do one on your own. Hot diggity dog. Number 12. Suppose 2 of the offspring from cross 3 with yellow coats are crossed. What percentage of the resulting offspring will have yellow coats? Okay, well, what do yellow-coated dogs have going on? What's in common between yellow dogs? Little e's, little e's, little e, little e, little e, little e. Okay, well, if you got 2, so what's in common for yellow coats? Little e, little e. So it doesn't seem to matter what's going on with the bees. So if we have e, make our little Punnett square, what do we get? We get all little e alleles for each one of these guys. So what's that going to be? 100% going to have yellow coats. Okie dokie, one left. Approximately what percent of normal gametes produced by a dog with this genotype will contain the capital B allele? If you know the answer is 50%, you can do that. Otherwise, you could set up a little square and and you say how many of those is that? That's 2 out of 4. That's 50%. Some simple things we can do with Punnett squares. You need to be ready to deal with Punnett squares, recessive and dominant traits, and some things from Bio 1. Dominant, capital, recessive, lowercase. Let's move on to the next one. All right, so you got another passage here, and you got some graphs, speed, drag, motor oil, glycerin, some pictures, but you're not going to read any of that. You're just going to jump right into answering the questions. You'll notice that this is a passage 6. This is at the end of the test. But you've got some really pretty easy questions hanging around here at the end of this test. So even though it's at the end, they're not all brutally hard, especially something like the first one. Let's look at the first one and see what it's given us here. Number 35, based on figure 3, tells us where to look. The depth of the steel ball in the motor oil at a time of 50 milliseconds would have been closest to which of the following? Okay. So we go up here, figure 3. We say, okay, here's the motor oil curve. We don't have 50 seconds, but if we did, that'd be about out here. What's that graph going to do? I don't know. It's going to be somewhere there up above 2. Got only one answer that goes along with that. So what are we doing there? We're just kind of sketching the curve out, continuing it out a little further and saying, okay, where is that? I don't know, call it 2.1. That's what we're doing there. That's an easy question. That's a really easy question, hanging out the end of the test for people who didn't manage their time well to guess on, or for people who do manage their time well like you to get correctly. Number 36, which of the following diagrams best represents the 3 forces that act on the steel ball? Gravity, buoyant force, and drag. I'll just remind ourselves, gravity should be acting down. So right away, I'm going to cross out the ones where gravity is acting in the up direction. It would be good if gravity acted down. Buoyancy acts up. So the difference is, what is this drag force, D? Does D go down or does D go up? What the heck's drag? Drag is a force that opposes motion. If you don't go and look what drag is, how are you gonna know? Opposes motion. Okay, an object falling through. Okay, so we got a ball going down. If the ball's going down, the drag's going up. This is what a parachute does. It generates drag, so you don't smack into the ground, after you jump out of the perfectly good airplane. So drag is going to act in the opposite direction of motion, so it's going to be G there. This ball's falling down through a liquid. As it's falling down, you ever tried to, imagine falling into syrup or something. You're not going to hit the bottom as quick as if you're falling into water. Don't jump into syrup. Number 37. A steel ball required less time to reach terminal speed. You don't know what that is. That's going to be a word search. In which liquid? Well, some of these are just wrong. Less time. Motor oil, the ball took 10 in motor oil, but 25 in glycerin. So we got some combos. We got some motor oil. Well, this says it took 25 seconds in motor oil, but 10 seconds in glycerin. Well, that's backwards, so it can't be B. And this one, we got a glycerin pair, less time, 10 milliseconds in glycerin, but 25. Okay, that makes sense because 10 is less than 25, but 25 isn't less than 10, so I can cross D out as well. So I really only got two answers that are possible because two of these are contradictory. What the heck's terminal speed? When the net downward force on the object equals the upward force, it's at terminal speed. If there's no forces acting on something, it goes the same speed. So when does it get to terminal speed? So looking at these two graphs, you say, when does it flatten out? Here it looks like figure 2, the speed flattened out around 8. Figure 1, speed flattened out around 25. This right here is the terminal speed. But I don't know, it doesn't tell me which one's oil, which one's glycerin. Okay, figures 1 and 2 show how the speed of the ball and the drag on the ball varied with time as the ball fell through the oil and the glycerin respectively. That means this is oil, this is glycerin. Which one got to terminal velocity at less speed? Looks like glycerin because it took about 10 there. That's going to be answer option C. That's a hard one. 3 left. What do I got here? What color? Going to black. All right, number 38. According to figures 1 and 2, the steel ball's terminal speed was greater in which liquid? Okay. Where did it have a greater terminal speed? Well, I got to look over here at these speed axes. Hopefully you notice, okay, terminal speed over here looks like something in the 40s. Terminal speed down here looks like something like 10. Who had the greater terminal speed? Looks like oil has the greater terminal speed. Crossing out H and J. 48 in oil, 10 for glycerin. What's answer G about? 240 and 210? 240 and 210 is if you look at the wrong side of the graph. That's the trap answer for if you look at drag. So G is a trap answer. You looked at the wrong graph, or you looked at the wrong axis. 2 to go. Number 39. Based on everything, okay, we're going to have to combine information. Is it reasonable to conclude that the drag on the steel ball was directly proportional? Well, you got to know what to the depth of the ball. What would that look like? Directly proportional would look like this. As depth increased, drag would increase. That would look like that. That's what it would look like. Does it look like that? No, it does not. because it becomes constant at some point. No, the depth increased only, whereas the drag increased and then approached a constant value. Okay. And the last one is just a hard one, just a hard one. Number 40, I like this one. You got figures 1 and 3 suggesting we're gonna have to combine some information at a drag of 0.5, at a depth of 0.50. What was the approximate drag exerted on the steel ball? Okay, so I know the depth, so that's where I need to start. Depth, where is depth? Okay, here is depth. I go out depth, 0.5. I go over to the motor oil. Great. And I go down. So I was at that depth at time 15 milliseconds. What was the drag at that time? I go back to figure 1. I go to 15 milliseconds. I go up to the drag curve, and I go over to the drag axis, and I've got a value right about, oh, what is that? Looks like it's closer to 270 then. Yeah, so 270. That's going to be H. It's clearly closer to 250 than 300, so I think that's why you'd go with that. 290 would be the dash line up there. So answer there, H, and you're good to go. You've got some group work number 5 to work on your own here. I'm looking through this guy. A few passages I might speak to before you go. We'll talk about them next time a little bit. Number 5, talking about something about sex-linked traits. Sex-linked traits are one that mothers pass to sons, because what does a mother give their son? Gives an X chromosome. Every mother gives their son an X chromosome. So often these are traits that are on the X chromosome. Just something I'll mention. And this passage, gosh, you don't know what any of this means, but if you read about up and down arrows, and if you look at the letter combinations and the up and down arrows, you can get a lot of things right just by matching up letters and noticing when it points up and when it points down. That's just a hard passage. I expect a lot of questions on that one. You should call into the Zoom meeting on group work for number 5, passage number 2. So that's what I got for you. Hopefully I kept that short enough. We'll see you later.